All right, welcome back to part 2 of our discussion, analyzing graphs of polynomial functions. So we went through this problem. This is from the last lesson. I gave you these answers. We graphed. All right, so now it brings us to our classwork problem 4.8.3, which I'm going to give to you right now. Okay, so we're going to use the x-intercepts to graph the function x plus 2, x minus 1, x minus 3. So go through all this process and then sketch the graph. So I'm going to let you copy this down. So I'm going to be looking for all these answers, 1 through 4, and then the graph as part of your classwork. And then I'm going to move on. Please copy this down. Okay, I'm moving on. All right, so you want to use a location principle to identify zeros of polynomials. Again, this is a very simple term, or a very simple topic, but might seem complex in mathematical speak. So let's talk about, so here's the location principle. So the location principle says if I have a point that's below the x-axis and a point that's above, and these 2 points are part of a function, then I have to cross the x-axis at least once. That's all it's saying. Or if I have one above and one below as part of a continuous function, then I have to cross the x-axis. So a pretty simple idea, but described as such. If f is a polynomial function and a and b are 2 real numbers, those are the values for x, such that f of a, the y value when you substitute a into the polynomial function, is less than 0, and f of b, that y value, is greater than 0, then there must be at least one real 0 between a and b. The graph has to cross the x-axis. All right, so that's all that's saying. All right, so we're not going to have any questions on that. And then we want to identify even and odd functions, and this may or may not be an extension for you depending on the year. Typically this will be covered in pre-calculus, but I'm going to go through it with you anyway. So even and odd functions different than even and odd degree functions. So an even function is where f of negative x is equal to f of x for all x. All right, so we can find out if that's true by replacing x with negative x and rewriting. And if the original function, x to the 4th plus x squared plus 1, is the same as f of negative x, where I substitute negative x in for x, then it's an even function. All right, so f of negative x, so I substitute negative x in for x here, and negative x to the 4th is the same as x to the 4th. Negative x squared is the same as x squared. So I can see that when I substitute negative x in for x, I end up with the same equation as the original function. So x to the 4th plus x squared plus 1 is in fact an even function. All right, odd function, when I can say that negative x, f of negative x, is the same as negative f of x for all of x. All right, so I have 2 steps here. I'm going to replace x with negative x and rewrite it. And so you can see I end up with x to the 4th plus x squared plus 1. And then I'm going to rewrite as negative f of x. That's negative x, right? I have to change all the signs. And so I look at negative f of x, and it's different than f of negative x. So then, since f of negative x and negative f of x are not the same for all of x, then this function is not odd. If they were the same, then they would be, the original function would be an odd function. All right, so let's see what you can do with these 4 functions. All right, so let's see if you can determine if the following functions are even, odd, or neither. So pretty challenging potentially for you to do this. Let's see what you can do. I'm going to give you the answers. You can check your work. I'm going to give you a classwork problem. All right, so here are the answers. You can check your work if you want. Pause and take a look. So I have odd, neither, even, neither. So this brings us to classwork 4.8.4. And I'm going to give you your last classwork set, and then we're going to be done. And then again, please check in with me about whether or not this is required classwork. All right, so these are 3 problems. Please determine if the following functions, I should really put f of x here. and then f of x here. Determine if these are even or odd functions or neither. So take a moment to copy these down. Please pause this. And that's it. So I'm going to end here. Thanks very much for joining. Great work on Chapter 4. And we'll see you next time when we move on to Chapter 5.